So far, so good. But have you noticed one thing? That so far that we have been discussing rolling, we have actually ignored a very important factor which causes rolling. I am talking about the surface of contact, which provides the friction, which then provides the torque, which actually is responsible for rolling to happen. So let us add the surface of contact and see what happens. Let's have a relook at the three cases that we just saw and add a surface of contact to each case. Remember, our surface must be sufficiently rough. The surface introduces friction, but only in the first and the third scenarios. The point Q in these two scenarios has a finite linear velocity parallel to the surface. This causes Q to slide on the surface, which, of course, produces sliding friction. There is no sliding friction in the second scenario because the point Q in contact with the surface has zero velocity. What does the sliding frictional force do? It obviously changes the linear motion of the body so that the velocity of the center of mass changes in magnitude. On the other hand, the sliding frictional force produces a torque around the center of mass, which of course changes the angular velocity omega. In the first case, the torque opposes omega and hence reduces it. The friction acts in the direction of the motion of the center of mass and hence increases the velocity of the center of mass. With omega decreasing and v increasing, soon the velocity of Q becomes zero. In the second case, just the reverse happens. Note that here the friction opposes the motion of the center of mass and hence reduces v. And the torque helps in increasing omega. In any case, in this scenario also, there comes a time when the velocity of Q becomes zero. As soon as velocity of Q becomes zero, Q does not slide on the surface anymore, and hence the force of sliding friction disappears. Beyond this instant, there is neither any net external force nor a net external torque acting on the body. This also means that the motion of the body does not change after this and theoretically continues in the state forever or till such time that there is no new force or torque that forces the body to slide again. This state of motion, where the magnitude of Vq or the velocity of the bottommost point Q is equal to zero, is called pure rolling. To summarize, during pure rolling, 1. The velocity of the bottommost point, which is in contact with the surface, is zero. And second, the velocity of the center of mass, that is Vcm, is equal to r omega.